Hello everyone and welcome to Realize Live 2022. In this presentation we'll be focusing on large assembly best practices in Solid Edge. My name is Ben Weisenberger. I'm an application engineer with the Global Technical Enablement team for Solid Edge. In this session we'll look at 5 best practices for working with large assemblies, including simplifying components, using data management, and optimizing our display. Then we'll talk about some recent enhancements to Solid Edge assemblies that will greatly benefit us while working with large assemblies. Some of these enhancements include fast assembly preview, internal components, and CAD Direct. Let's get started. First, we'll talk about simplifying our components and why this is important. The biggest impacts you can have on assembly performance is to simplify parts, especially if they are reused often. For example, if your model includes a lot of hardware, you likely don't need details like helical threads, markings on the head, or small fillets of a bolt to show up in the bill of materials or the drawing. If showing head shape and the body of the screw extruded to the correct depth are sufficient, simplify your part accordingly. In many cases, modeling just the head of a screw or bolt is enough representation of a standard part in a large assembly. Best-in-class CAD systems like Solid Edge software also support occurrence property options, which allow you to cull components such as bolts and fasteners from upper-level assembly models. Also consider your analysis needs when determining how much detail to show. Unless you are the bolt manufacturer, you likely don't do in-depth stress analysis on bolts in your assembly, so very few companies really need to represent these parts with a high level of detail. If you do interference checks and mass calculations at the subassembly level, you need to have a fairly accurate representation of your hardware, but you might be able to get away with a very simplified representation of your hardware at the upper level. Remember that the computer must draw every edge that you create, and if you have hundreds or thousands of screws, a single extra edge on the screw means your computer has to redraw those extra thousands of edges. The same sort of idea applies for electronic components on circuit boards, purchased motors or pumps with a lot of detail. When your assembly includes a subsystem that is either purchased or provided by a supplier, simplifying it to a single part file enables you to design in context without impeding performance. Define cohesive sets of parts, features, and constraints as a single functional system, and then use this model in your actual design. The time you spend up front will improve both performance and model accuracy. Here we'll look at how we can simplify a model quickly inside a Solid Edge. Our goal is to take the grinder assembly we see here and simplify it down to one part file so that we can reduce the file size when placing it into a larger assembly, or to be able to share it with customers without giving away any proprietary information. If we start by creating a clipping plane, we can take a look at the internals and the individual components that make up the assembly. When we simplify the model, we want to make sure we're removing all of the intelligence and components from the inside. Next, we'll switch into the Simplify environment and enter the model method of simplification so that we can begin to do our work. The model simplification method, we could create primitive shapes that represent each of the parts in the assembly, or we can use the auto simplify command to help speed up this process. After running the command, we will fence select the entire assembly and hit accept. We hide the background components and turn on the clipping plane that we created earlier. We can then see the results. Part files have been booleaned together to create a continuous connected part file. Internal voids on each part have also been filled in. Now, if we want to remove all voids and completely fill in the entire assembly, we can toggle an option on the command bar to do just that. We're now left with a shell of the original assembly that can be saved as a part file and shared with vendors or customers, or used down the road on another assembly to help save memory. Next, we'll focus on using large assemblies inside of drawings. Drawings have a big job when it comes to large assemblies. Multiple views of each assembly, including multiple parts, and potentially cutaway, detail, or exploded views mean that your CAD tool has to manage the display of a lot of different states. You want to avoid interferences where possible to keep your drawings performing well. When your solid model has interferences, it can cause display issues, which means that your system is spending more time calculating that bad display than it should. Make sure to check for interferences if you see anything amiss in your assembly views. Detail is great, and enthusiastic new 3D users sometimes get obsessed with how much detail they can create. You can make bolts look very realistic, right down to the grade markings on the head, rounded edges, textures, and highly detailed helical threads. The problem with detail is that it is costly in several ways. First, detail takes a long time to create. Second, it takes a long time to display it every time you need to do so. Too much detail can have a critical impact when it comes to drawing performance. Drawings must calculate every edge and then decide if they are hidden, shown, grayed out, or dashed for every part every time it is shown. Excessive detail can make your model look more realistic, but causes performance losses as a result. Up next, we'll talk about ways to improve your models. Some things you do in the assembly take up more computational resources than others. Assembly features, for example, require the assembly to make sure the parts are updated, bring the parts into the assembly, position all the parts, and then add a feature to those position parts with potential differences between part occurrences. So that can really add up. Inter-part relations are also very costly for the same reasons. This is one of the reasons why synchronous parts and assemblies are recommended for better performing assemblies. You can create relationships between parts in an assembly only when needed, without the associative links. Also, consider freezing links when you're done working with an area of an assembly to further improve your performance. An important part of working with large assemblies is how you manage the files. So let's talk about how PDM systems can help. Another common source of performance problems comes from referencing files stored across a distributed network. The best way to avoid performance problems due to networked files is to use a product data management system. PDM systems can be more cost-effective than many companies realize and can result in substantial performance gains. Now, while the PDM vault is in a central location, when you check files out to use them, they are copied down to your local machine. The PDM system can accomplish this in a way that doesn't cause problems with duplication, overwriting, or permissions. This gives you the advantage of working on shared files without the normal disadvantages of sharing files across the network. PDM also helps you avoid complicated rules aimed at avoiding overwriting other users' changes, revision control on solid models, and tons of additional and confusing file management problems. If you're concerned about assembly performance, a simple PDM tool should be a priority. Now, network speed is a separate infrastructure issue impacting performance, but a PDM solution can greatly improve how your system performs within your existing IT constraints. Now, Siemens provides a scalable set of data management solutions that meet the varying needs of small to large manufacturing organizations who may design simple or very complex products. These solid edge CAD data management solutions enable you to rapidly take key actions to improve product development performance. You can secure and control your product data and processes, enable rapid retrieval of the correct information to improve efficiency and facilitate reuse, share product information and collaborate with downstream functions such as manufacturing to improve quality and reduce costly errors, and follow industry best practice workflows for engineering change and release to manufacturing. Solutions range from integrated data management capabilities that are included with Solid Edge to the comprehensive CAD data management and product lifecycle management capabilities of Teamcenter. Finally, let's take a look at how to optimize our display to make it easier to work with large assemblies. Visual effects can help convey an accurate look and feel and create a realistic look to communicate with partners, customers, and your shop floor. But in upper-level assemblies, where system performance becomes an issue, consider the trade-off between parts that look cool and faster modeling capabilities. To optimize upper-level assembly performance, you may want to turn off reflections, drop shadows, cast shadows, and silhouettes. Use shaded without edges or single edge color if you use visible edges. We also want to use culling, set our sharpness to low if possible, turn off view transitions, and turn off glow. So these are all great ways to help with your display performance on your large assemblies. Huge strides have been made in the last couple of versions of Solid Edge to help with large assembly performance. Let's walk through some of these enhancements to see how they can help us be more productive while dealing with large assemblies. First up is Large Assembly Performance Mode. New High Performance Mode is available for large assemblies starting in Solid Edge 2021. This mode changes display and interaction settings to help improve performance and memory usage, and is based on some of the settings we just talked about. Users can toggle this mode on or off, but Solid Edge will also automatically enter this mode based on the total number of components in the assembly. Here we can see some of the view settings that are turned off while the mode is active. These settings include view transitions, shading, glow, and reflections. Quality rendering settings such as shadows and bump maps are turned off in addition to using the accelerated display settings on all sketches in the assembly. Large Assembly Performance Mode is a great way to increase graphical performance, making it easier to work with large datasets. Next, we'll look at an enhancement added in Solid Edge 2022, Fast Assembly Preview. Large Assembly Preview allows us to open assemblies of any size in a matter of seconds, even with tens of thousands of parts. We can then manipulate the display, hiding and showing parts, changing display configurations, all with a view to simply focus on the area of the design that we need to work on, then ultimately edit the assembly. All this allows us to work faster, saving valuable time. Let's take a look at an example. Here we have a large assembly, around 6,000 parts, and we want to see how quickly we can open this. During the last save of this file, the preview geometry was saved to the file, allowing us to open it faster in the future. Once opened, we can manipulate the model normally using zoom, pan, rotate, etc. Parts can be highlighted and selected either graphically or from the Pathfinder. We can expand subassemblies to dig in deeper, and if desired, we can hide components. Looking at the ribbon, we see a condensed layout containing select commands, display configurations, which we can change here, Large Assembly Performance Mode, which we covered previously, measure commands, orientation commands, and finally the Edit Assembly command, which allows us to fully open the assembly. We can determine how we want to open the assembly. Here we'll use Auto Select, and then Solid Edge will begin to process the assembly and open it. New dialog appears in the bottom left, which indicates that the files are being accessed and the assembly is opening. Once open, we see we have access to all the normal assembly commands and can begin doing our work. Now, if we need to work on other parts of the assembly that aren't currently shown, we can load those other components by turning them on in the Pathfinder or by simply changing the display configuration. What we saw there was that when opening the assembly, due to its size, it opened very quickly into the preview environment. In here, we're able to easily change the scope of what to ultimately load by hiding and showing parts, either graphically or through display configuration. And then once we're happy, we can simply choose to edit the assembly. The benefit being that since we've reduced the number of visible parts, the assembly that we wanted to work on was open much, much faster. So this fast preview capability is achieved by storing the preview geometry right inside of the assembly file itself. We have an option we can use to control this under Solid Edge Options, General, and it's worth pointing out that storing the geometry in the assembly does increase the file size, but the benefits far outweigh that fact. During file open, we can also get Solid Edge to automatically detect whether we should enter preview mode based on the size of the assembly using another option on the Assembly Open As tab. If it's large, enter preview mode. If it's not, then we'll simply just open the file. Also, when opening Assemblies, you'll now see a new dialog showing the progress. The great thing about this is you can choose to stop the process in order to simply display what Solid Edge has loaded so far. Thought it was also worth pointing out the benefits of using preview mode on a moderately sized assembly. Here you can see it would have taken just under 1 minute to fully open up this factory, which has around 12,500 parts. However, we can open it into preview mode in just 8 seconds, then change the display to focus on what we want to work on, in this case the tanks. Then when we choose to edit the assembly, it takes just 7 more seconds to fully load that part into the structure. Some really impressive time savings, which would be even greater on a larger design. Let's look at internal components and talk about how they can help with large assemblies. Internal components were introduced in Solid Edge 2021. They give us the capability to import very large data sets into a single assembly file, for instance, a step file of a large assembly. The result is a single assembly file with a complete assembly structure but without any additional part files on disk. So it gives us a huge performance boost when working with and importing foreign data sets. We can then maintain the structure as it is, or we can publish it in order to create the full file-based structure. If we decide to publish the internal components, it will convert their structure to a traditional file structure and create those files on disk. When you go through the publish process, you have choices for what templates to use, location to save the files, as well as materials for part and sheet metal documents. And in case you were wondering, assemblies can contain both internal components and normal external parts. Assembly relationships can also be applied between both types of components as well. Let's take a look at an example. We have a Parasolid assembly that we would like to open as an internal component. If we browse to our desktop and filter our files to see only Parasolid file types, we can see the file we're looking for. Opening the options, we see the setting to open this as an internal component. Let's toggle that on and then open this model using an ISO assembly template. Looking at Pathfinder, we can see the icons for each part file are different from what we're used to. These icons indicate that the models are internal components. Using the Assembly Relationship Manager, we see that by default, Solid Edge has applied a ground relationship to all of the parts. We'll delete a few of these relationships so that we can create the correct constraints for this assembly. Next, we'll run the Relationship Assistant and tell it what we want to create the relationships between all of the components that we select. Through fence selecting the entire model, we can tell Solid Edge to only create mate and axial line constraints and then process our selection. To prove that the constraints were created, we can use drag component to move the assembly. Internal components can not only save us time with opening larger assemblies, but also save space by not having unnecessary files on disk. Later down the road, if the files are needed, we can simply publish the internal components and use them as we normally would. A great new enhancement for Solid Edge assemblies. Next, we'll talk about the ability to work with components while they are inactive. Starting in Solid Edge 2021, support was added to allow us to work directly with inactive parts, bypassing the need to activate components to do certain assembly workflows. This enhancement greatly improved performance by lowering the required memory and overall helps improve usability. If necessary, users have the choice to turn this capability off, either on the ribbon or in the Solid Edge options. If the option is turned on, then we're able to do the following workflows on inactive components: create assembly relationships, measure and add PMI dimensions, use view commands such as look at face, as well as synchronous moves. Let's take a look at an example to see some of these workflows firsthand. First thing we'll do is inactivate all of the parts in the assembly. You'll notice that as we hover over the assembly, the individual parts are highlighting, even while inactive. Now, we just covered some of the supported workflows for inactive components, one of them being look at face. In the past, we had to activate the part before using this command. But now we simply run the command and click the face without activating. We can also use 2D measure commands and take measurements between inactive parts. The 3D measure command works as well. Inactive parts can even be assembled. First, we'll place another copy of this part. Delete the original, and then inactivate the copy that we brought in. Using the assemble command, we can start picking faces on the mounting block, and then the corresponding faces in the rest of the assembly. And just like that, we've added assembly relationships without needing to activate the part first. A great new usability enhancement to Solid Edge assemblies. Another great recent enhancement is the Component Finder. This assembly productivity tool gives you the ability to very quickly search for and find parts within your assemblies. An entry field is located at the top of the assembly pathfinder. You can simply start typing a part name into the field and it'll begin to auto-complete, gradually narrowing down the appropriate results. The parts that it finds will be highlighted in the pathfinder and the graphics area. You can even use wildcards for the search terms too. So really nice everyday functionality. Last enhancement we'll talk about today is CAD Direct. Direct gives us the ability to reference foreign CAD data directly into our assemblies without the need for translation. We support NX files and have also added support for SolidWorks, STEP, Parasolid, and JT with a recent 2022 maintenance pack. Other formats will be introduced in the future as well. Now, CAD Direct is really useful if one of our suppliers, for instance, uses a different CAD solution. We can just reference their data directly and use it in our designs without translation and without creating any extra files on disk. The link to the files is associative, so if they are changed by our supplier, we can update them in Solid Edge at the click of a button. If necessary, that link can be broken easily too. For the update, any downstream features that have been applied will also be updated. For instance, if we've applied some assembly constraints to position the foreign data, these will update. Another example could be where we've used the geometry in the foreign assembly to create sketch geometry for features in the other parts. These features can be made associative and would update as well. It's a really great functionality that improves supplier collaboration and can reduce large assembly file size. So to learn more about Solid Edge 2022, visit us at siemens.com/solidedge2022 or simply use your smartphone to capture the QR code pictured here. Also, if you're not already a member of the Solid Edge Community Forum, I highly recommend you join. Once a member, you'll have access to a wealth of knowledge, be able to browse blog postings, read articles, and hear about the latest news from Solid Edge. You can also ask questions, exchange ideas, and benefit from other user experiences on our moderated forum. And finally, you'll have access to our extensive knowledge base from which you'll be able to increase your skills. So join now. That wraps up this session on large assembly best practices in Solid Edge. Hopefully you found this session useful. Thank you for your time and have a great day.